everyone. Sorry about that. Hope to see you back soon. Um, we want to just go ahead and let everybody know that we had to switch channels. So um, we're going to be reviewing for today's test. And hopefully you guys will be able to join in. Welcome back. We're going to go ahead and get started on today's review. Apologize for the delay. So what we're talking about today is the end of unit test. So a couple of things I wanted to review. I looked at some of the questions that people didn't understand. So I want to go over that style of question and show everyone, what they're going to be looking at in terms of improving for the retake. So one of the biggest issues that I noticed was practicing density problems. The formula for density, we have density is equal to mass over volume, but we also have this triangle here, okay? And it is density and volume are next to each other and mass is on top. You have to understand how to manipulate the formula so that you're able to solve for what you want to solve for. So in this case, if I want to solve for mass, mass is equal to density times volume. And volume is equal to mass divided by density. So in terms of practice problems, if we have an item that has a mass of 20 grams and its density is 5 grams per cubic centimeter, then what is the volume of the substance? So we would take we're solving for volume, so volume is mass divided by density. So it would be 20 grams divided by 5 grams per cubic centimeter. So this particular item would have a volume of 4 cubic centimeters. Okay? So let's look at another example. So this was a big one. I'm going to move these over a little bit so that I have more space to do problems. Density is equal to mass over volume. Volume is equal to mass divided by density. And mass is equal to density times volume. So let's say we're looking at two substances simultaneously. Hi, Rosie. Hello, Noelle. Okay, so what we're looking at in terms of this particular problem, you have the density of water. So let's say we have water and we have, let's say, oil. Okay? So water has a density of 1. Okay? It has a volume of 50 cubic centimeters. The oil, let's say, this particular oil has a density of 0.5 grams per cubic centimeter. This is grams per cubic centimeter. Okay. And its volume is unknown. Its mass is unknown. Here, the mass of water is unknown, but let's take a closer look. We know that water has a density of 1, and we know water's volume is 50 cubic centimeters. Well, if you want to solve for mass, mass's density times volume is equal to 50 times 1 is equal to 50 grams. The density of the water is 1 times its volume, which is 50, means it has a mass of 50 grams. So now that we've solved everything here, now we can look to see, okay, we're missing 2 things in this problem. Well, what are we looking to do? Hi, Coral. So the problem reads, the density of water is 1 gram per cubic centimeter, and the density of oil is 0.5 grams per cubic centimeter. What is the volume of oil in cubic centimeters that has the same mass as 50 cubic centimeters of water? Okay? So, well, we know that now the mass here is 50 grams. So it says, what is the volume of oil that has the same mass as 50 cubic centimeters of water? Well, 50 cubic centimeters of water has a mass of 50 grams. So here, we now know that the mass that they want to use in the problem is 50 grams. Okay? So, since the mass is 50 grams, and we know we have 0.5 grams per cubic centimeter, we can now solve for volume. The formula for volume is mass divided by density. So it is 50 grams divided by 0.5 grams per cubic centimeter. Okay? So if we do our math, and I want to make sure the math is correct. Okay? 50 divided by 0.5 gives you 100 cubic centimeters. So the volume of oil that has a mass of 50 grams is 100 cubic centimeters. Does that make sense? Does anyone need me to go over the problem again? And you can always go back and watch this because it will upload once I finish streaming. Okay? All right. So let's go to another problem. I'm going to do all the math ones at one time. Follow some continuity. All right. So some of the problems that I noticed people had issues with. Oh, you need me to go over it again? Okay, I'll go back to it. So some of the problems that I noticed people had issues with were the tables, okay? For example, you have 3 items that are measured, and those 3 items are listed in a table, okay? Which items could be made of the same material? So let's say I have item A, B, and C, and I'm just gonna make up some numbers, okay? So we have the volume of the item and the mass of the item. So this item has a volume of 20 cubic centimeters and a mass of 5 grams. Okay? Oh, let me not do that. Let me actually reverse that. We're trying to make these numbers easy. So 5 cubic centimeters and 20 grams. Okay? And this one has a mass of, let's say, 25 grams and 5 cubic centimeters. And this one has a mass of 32 grams, and it has a volume of 8 cubic centimeters. So you want to figure out of these three, which two could be the same. Well, we're solving for density. Density is mass divided by volume. 20 divided by 5 is 4. 25 divided by 5 is 5. And 32 divided by 8 is 4. So the answer is blocks A and C would be the same substance because, or could be the same substance based on this chart because they have the same density. Does that make sense? Yes, no. I need a little quick feedback here. Okay. All right. So there were a couple of questions like that. And those questions didn't have some issues. So now let's say we have 4 samples, A, B, C, and D. Okay. And one sample has a mass of 5.4 and a volume of 2. So this is volume and this is mass. One sample has a mass of 8.9 and a volume of 3. This has a mass of 6.2 and a volume of 8. This has a mass of 10 and a volume of 5. So the question says you're trying to identify a type of metal, and in that metal that you're trying to identify, you have the mass and the volume of each. So these are your metals. Which one of these metals could possibly, I know you are, Kaden, which one of these metals could possibly be aluminum? Well, if you do the math for all of these, 5.4 divided by 2 is 2.7. Okay? 10 divided by 5 is 2. I'm just going quickly here. 8.9 divided by 3 is 2.97. And 6.2 divided by 8 gives you a 0.775 or 0.78. Well, if I tell you that the density of aluminum is 2.7, well, then the only possible substance that could be aluminum is A. Does that make sense? Yay or nay? So basically, the problem tells you what the known mass and volume of an aluminum block is. So you would calculate the aluminum. And then once you calculate what the density of the aluminum is, you would compare it to these 4 and get it. Okay, so you would have to do the calculations for all of them. All right, so moving on. Okay. We know that density is a characteristic property of a substance. And what that means, it means no matter how much or how little of a substance you have, the density is exactly the same. So we're going to go ahead and we're going to graph that. Okay? I'm going to make the graph bigger than I did in the last review. All right? So if I have a graph 0, 2, 4, 6, 8, and this is volume in cubic centimeters. And I have the density of the object here. Okay? Well, let's say we have aluminum because we know the density of aluminum and we use water a lot. Okay? Well, if I have 2 cubic centimeters of aluminum, well, the density of that 2 cubic centimeters of aluminum is 2.7 grams per cubic centimeter. Well, if I have 4 cubic centimeters of aluminum, its density is 2.7 grams per cubic centimeter. If I have 6 cubic centimeters of aluminum, its density is 2.7 grams per cubic centimeter. If I have 8 cubic centimeters of aluminum, its density is 2.7 grams per cubic centimeter. So, if you were to connect the dots, that's what your graph looks like. So as you can see, density is a characteristic property of a substance. So it is the density relationship to volume is linear and it is a horizontal line. Because no matter how much or how little of the substance you have, the density of the object does not change. Okay? All right. Does everybody understand that? Does that make sense? If I can get a yes or a thumbs up just to make sure that it's making sense. Awesome. Okay. All right. So next. And again, if you've missed any part of this video, it will upload so you'll be able to go back and watch it again. Okay, so the question that I had originally posed, and I said I would go over it again. You have water and oil, okay? And we said the oil has a density of 0.5 grams per cubic centimeter. Water has a density of 1 gram per cubic centimeter. So this is density. The volume of the water was 50 cubic centimeters. The volume of the oil is unknown. And the mass of the water is, for now, unknown. And the mass of the oil is unknown. So that's how we go into the problem. Now, the question reads, the density of water is 1 gram per cubic centimeter. The density of the oil is 0.5 grams per cubic centimeter. What is the volume of ethanol that has the same mass as 50 cubic centimeters of water? Well, we look at oil, we can't calculate anything with one variable. But if we look at water, we have density and volume, we can calculate the mass. So if you look at mass, mass is density times volume. So density times volume is equal to 1 gram per cubic centimeters times 50 cubic centimeters. And that equals 50 grams. So we now know the mass is 50 grams. Well, the question says, what is the volume of oil that has the same mass as 50 cubic centimeters of water? Well, 50 cubic centimeters of water has a mass of 50 grams. So we now know that the required mass of oil is 50 grams. Okay? So then, now that we have that information, we can go ahead and now solve for volume because we have two variables. So volume is mass divided by density. So mass divided by density is equal to 50 grams divided by 0.5 grams per cubic centimeter. And that comes out to 100 cubic centimeters. Does that make sense? I know, Cora, you were asking me to go back over that. Does that make better sense now? Yes, no, maybe so. Yes, awesome. Perfect. Okay. So, those were pretty much the issues that I found. The biggest issues that I found were the calculations of density problems where people were unable to correctly use the formula. So this is something you really want to focus on. Is there anyone who has a question that they want me to do, something they want me to do or show? I'm going to go ahead and clean this off, but if you can go ahead and let me know what you want me to go over, I'm happy to do that. While you're typing that, let me just go ahead and review. In a graduated cylinder, okay, in a graduated cylinder, when you read a meniscus, you read from the base of the meniscus. Okay? That's how you read a meniscus, to make sure that you can actually get the correct volume of water. Now that meniscus is very greatly exaggerated, but that's so you can see what we're looking at. Okay? Does anyone have a question they need me to go over, something they need me to explain a little bit better? Does that help in terms of solving those problems? I know those were the biggest issues. I think in terms of the tables, what I saw were the tables and substitutions, okay, which is what I really addressed here. There is something else I want to address. Okay. So one of the questions that I know some got wrong, and I think it was solely because of the inability to actually process the question correctly. One of the questions was having to do with measuring physical properties. Okay, so, and this goes back to something that I explained earlier. Density is a characteristic property of a substance. No matter how much or how little of the substance you have, the density will never change. So if you're measuring physical properties, if the mass of a substance increases, for example, if I were to take this bottle and I were to fill it with, well, okay, perhaps water is not the right example. If I were to take a box, okay, and I were to make the box bigger, okay, the mass of the box increases, the volume of the box also increases. So if you were to have a pile of clay, and you sit there and you take another chunk of clay and you add the clay to it. You take another chunk of clay and you add the clay to it. Well, you're adding matter, right? So since you're adding matter, well, the mass is going to go up. But that lump of clay is also physically getting bigger. The volume is going to change as well. My question is, the density change. See, if I took this box, okay, the box itself is made up of more than one material. I have the paper of the box, but the inside of the box has cans in it, which are aluminum, and the liquid inside of the aluminum is carbonated water. Now, the density of the water is 1, but there's also the density of the carbonated gas, which is very, very low. Carbon dioxide has a density something like 0.000084 or something like that. I don't remember exactly what it is. Okay? So you have multiple substances there. So if you put something in a box, you have multiple substances. But if you're taking, so you can't really calculate the density of that. You know the density is increasing. The density is changing, but because you're putting multiple substances in a finite space. But when you're talking about a pure substance, for example, clay, okay? If you were to take that piece of clay and start adding more clay physically to it, well, the amount of clay that you have is increasing, so the mass is going to increase. But the lump of clay in your hand is also going to physically get bigger. If it's the same type of clay, the density doesn't change because density is a characteristic property of a substance. Okay, so that's something you have to pay very close attention to. Density of a substance will never, ever change. Okay, water's density, if it's pure water, its density is always going to be 1. Now, salt water is different than pure water. Its density is greater than 1. Okay, that's the reason why people can actually float in salt water. Okay, because its density is greater than 1. Okay, so hopefully that clarified that a little bit. There were a couple of people who said if the mass changes, density can change. Density doesn't change for a pure substance. Okay, are there any questions that I can answer for you? Okay, last bit of advice that I can give on this test. Please make sure you read the questions carefully. I noticed people finishing the test in a very short window of time. You're not answering the questions correctly because you're glossing over the questions. Please read and digest the questions carefully. Make sure you understand exactly what the question is asking. Because there were some who, when they went back and looked at their questions, said, oh, I read that wrong. Okay, and you don't want to lose points for reading a question wrong. So that's pretty much it that I have to go over. If you have any questions, you can feel free to put it in the comments at the end. And I'm happy to help you in any way that I can. But if not, I look forward to seeing you tomorrow. And I hope you have a wonderful night. Thanks for joining me. Bye.